There is a very specific, very visceral kind of anxiety that hits every developer eventually.
Oh, yeah.
And it's not the panic of a server crashing at 3 a.m.
Mm.
It's a lot quieter than that. It happens when you open a file, usually when you wrote yourself maybe 3 or 4 months ago, and you just freeze.
Right. The classic wall of text paralysis.
Exactly. It's like opening that one drawer in your kitchen. You know the one?
The junk drawer.
The junk drawer, where you shoved a screwdriver, maybe 3 soy sauce packets, a random ball of twine, some batteries that might be dead. It started with good intentions, but now it's just this monster.
Right, and you're afraid to touch it because if you move one thing, the whole pile collapses.
Exactly.
In software architecture, we actually have professional names for that kitchen drawer. We call it the God object or the big ball of mud.
Big ball of mud is so accurate.
It is,
Yeah.
and it's not just a mess, right? It's a literal manifestation of entropy. Systems naturally drift toward chaos unless you actively apply energy to organize them.
Well, today on the deep dive, we are actively applying that energy. We are fighting the entropy. We're looking at a really fascinating case study from a developer named Ang.
Who writes under the handle kian.org, yes.
Right. And I have to say right off the bat, he has one of the best self-descriptions I've ever seen on a tech blog.
It is fantastic. He calls himself an old software plumber.
Old software plumber. It's so humble.
Yeah.
Right? It implies he's not out there just building shiny glass facade skyscrapers. He's down in the basement making sure the pipes don't leak and that the water actually flows to the 10th floor.
Precisely. It's a very pragmatic view of coding. And today, we're analyzing his notes on Haskell Programming, specifically Part 66.
And yes, there are a lot of parts. We will definitely get to that later.
We will. So he's working on this console application called X2 ebook, and he ran into exactly the problem you just described. His main test file, which is test/spec.hs, was becoming a totally bloated nightmare.
And the mission for this deep dive today is to unpack the solution he found. Because he didn't just, clean it up manually by cutting and pasting things into different folders.
Right, which is what most people do.
Exactly. He found a way to completely automate the organization using a tool called hspec-discover. It's essentially a magic trick for decluttering your code.
It is a magic trick, but I'd argue it's also a masterclass in a core engineering concept called separation of concerns. It's about how to structure your work so that the computer does the heavy lifting of organization, which leaves your human brain free to focus on the actual logic.
So for you listening, let's set the scene before we get to the fix. Ang is building this tool, X2 ebook. It converts things to ebooks, presumably.
Safe assumption.
And like any responsible software plumber, he's writing tests to make sure his code actually works.
Right. And in the Haskell ecosystem, the standard way to write tests often involves a framework called hspec.
HSPEC.
Exactly. It's a behavior-driven development framework, or BDD for short.
And BDD is the one where the code reads almost like plain English, right?
Yeah, exactly. You literally write out, describe this function, it should do this specific thing. It's very readable.
Okay, so he's writing these descriptions for his app. Things like, it should check the version, it should parse a text file, it should display the help menu. And initially, he's just dumping all of these tests into one single file, that spec.hes file.
Which, to be fair to him, is the absolutely right move when you're just starting out.
Really? Just dumping it all in one place?
Oh, yeah. It's low friction. You have one window open, you write your app code, you tab over or scroll down, you write the test. It's fast. There is zero context switching.
But then the project grows. The kitchen drawer starts getting full.
Always does.
And Ang points out 2 very specific pain points that emerge from this. The first one is pretty obvious navigation.
Yes.
Scrolling through 2,000 lines of code just to find the one test that's failing is miserable.
It's cognitive load. That's the real cost there. Every single time you scroll past a function you don't need right now, your brain unconsciously parses it anyway.
Oh, that makes sense.
It drains your mental battery. You're spending precious energy just actively ignoring things.
Right. But the second pain point he mentions is the one that really resonated with me, and I think it will resonate with anyone who works on a dev team. Merge conflicts.
Oh, this is the killer. This is the absolute bottleneck of software development.
So explain how this happens with the big bloated file.
Okay, imagine you and I are working on this XS2 ebook app together. You are assigned to fix a typo in the help menu. I am adding a completely new feature for, let's say, PDF support.
Okay.
We both write our code, and we both go to add a test to prove our code works.
And since all the tests live in that one test/spec.hs file?
We're both editing the exact same file at the exact same time. And usually just out of habit, we're both trying to append our new test to the very bottom of the file.
So when we try to merge our code back into the main project branch,
Git absolutely panics.
Right.
It sees two different people trying to write completely different things to line 500. It throws a merge conflict. So now our coding stops. We have to get on a Slack call, look at the code together, and manually resolve whose test goes where.
it turns a creative, productive process into a bureaucratic one.
Exactly. It's friction.
So the goal is clear. Ang says in the post, I've always preferred isolated modular test codes. He wants to break this big bucket into small cups. One file for help tests, one file for version tests, one for text file tests.
Which sounds totally simple. I mean, in many modern languages, like JavaScript, if you're using Jest, or Python with PyTest, you literally just create a new file named test_whatever.py, and the test runner just magically finds it.
It scans the folder, right?
Yeah, it scans the directory and says, ooh, a test, I'll run that. It's completely implicit.
But this is Haskell. And Haskell is, well, let's call it particular.
That is a very polite word for it. Haskell is aggressively explicit. It loves safety, and it loves correctness. It absolutely hates ambiguity.
So you can't just drop a file in a folder.
No. Typically in Haskell, if you add a new module or a new test file, you have to explicitly tell the compiler, hello, I have created this file. Please acknowledge its existence.
It's like filing a permit for your code at the city planner's office.
That is exactly what it's like. You
Okay.
file the permit, and then you have to go to your main test file and manually write an import statement, something like, import my new test.
Okay.
And then you have to scroll down and add it to the giant list of tests to actually run.
So it's this multi-step, completely manual registration process every single time you create a new file.
Yes, and that manual step is a massive point of failure. Humans are notoriously bad at manual repetitive steps.
Right, because we forget.
Exactly. If you create a file called superimportantsecuritytest.hs, you spend hours writing it, but then you forget to add it to the main list in spec.hs.
Wait, do the tests pass?
The tests pass.
Oh, wow.
They pass perfectly, but only because your critical security test never actually ran. The compiler didn't know it was there.
That is terrifying. That's a false positive.
The worst kind. You think your app is secure, you push it to production, but you're actually vulnerable.
Okay, so this brings us to the real aha moment of the deep dive. The specific solution Ang documents in part 66. He found a way to completely bypass this manual registration using that tool, hspec-discover.
Yes.
And it basically boils down to one incredibly weird-looking line of code.
Ah, the magic pragma.
The magic pragma. I love that. I'm going to read it out, and then you are going to have to decode it for us because it looks wild.
Go for it.
So this goes at the very top of the test/spec.hs file. It says bracket dash hash option s underscore ghc dash f dash pgmf hspec-discover hash dash bracket.
It really rolls off the tongue.
It looked like someone mashed the keyboard while holding down the shift key.
It does look a bit arcane. It looks like a spell incantation. But this is actually standard Haskell compiler instruction syntax. Let's break it down because understanding this one line is key to understanding how all the automation actually works.
Please do. Start with the options underscore ghc part.
So GHC is the Glasgow Haskell compiler. That's the engine under the hood that turns your human-readable Haskell code into a running machine program.
Okay.
This part of the line is just a direct message to that engine. It's saying, hey, compiler, I have some special custom instructions for you regarding this specific file before you do anything else.
Okay, that makes sense. And then the dash F, what's that?
Dash F stands for filter or preprocessor. It's telling the compiler, stop. Do not read this file directly. Do not try to compile this file yet. I want you to run it through a completely separate program first.
Oh, interesting. It's like a gatekeeper. Or, no, it's like a sous chef, prepping the ingredients before the head chef even starts cooking.
That's a perfect analogy. The compiler is the head chef, but it's busy. It has a lot to do. So the dash F flag calls in the sous chef to prep the station.
And so the next flag, the dash PGMF, I assume that stands for program filter.
Right. It's telling the compiler exactly which sous chef to hire for the job. And in this case, we are telling it to use hspec-discover.
Okay, I see the whole picture now. So effectively, Ang deletes all the code in his main test file. All those manual imports, all those giant lists of test functions.
Well, of it, gone.
And he replaces it with this one instruction that basically says, hand this directory over to the hspec-discover robot.
Correct. And that robot, hspec-discover, is actually Very simple, but incredibly effective. It scans the file system. It looks at the folder where the spec.hs file lives.
Right.
And it just looks for any file ending in the word spec.hs.
Which is the naming convention he decided to use for his modular files.
Exactly. So it finds help-spec.hs, version-spec.hs, txt file spec.hs. It automatically generates all the boilerplate code needed to import them, and it groups them into a single test suite.
Wow.
It writes the code you used to have to write manually, and it does it in milliseconds before the main compiler even looks at it.
So if I'm working on this app tomorrow and I add a brand new file called newfeaturespec.hs, I don't have to touch that main spec file at all.
You touch absolutely nothing. You just save your new file, you go to your terminal, run the test command, and the preprocessor discovers it, writes the import, and runs it.
That is incredibly satisfying.
It effectively turns a static, error-prone manual list into a dynamic, self-updating system.
It removes the chore entirely. It's automation in the truest sense because it removes the human error element. You literally can't forget.
And it removes the risk of that terrifying false positive we talked about earlier. You can't forget to import a test file anymore. If the file exists in the folder, it runs, period.
So let's look at the result of this. Aang actually shares the tree output in his post, like the visual folder structure, after he makes this change. And compared to that bloated kitchen drawer description, this looks delightful.
It's very, very clean. Instead of one giant, unreadable file, we now see a clear semantic breakdown. We have help-spec.hs, we have txt file spec.hs, version spec.hs, and he even has a test helpers.hs for shared utility code.
I want to drill into one of these specific files, help-spec.hs, because the source actually provides the code for it. And I think it really shows the tangible benefit of this kind of isolation.
Go for it. Walk us through it.
So the file starts with module help-spec, where standard Haskell module declaration. But look at the imports right below. It just says import test.hspec and import test helpers. That's it.
That is huge. Think about what is not there.
What do you mean?
It's not importing the complex code for parsing text files. It's not importing the code for handling version numbers or command line arguments that don't relate to help. It has zero dependencies on the rest of the application.
It's basically a clean room.
It is a clean room. In software design, we talk a lot about coupling and cohesion. You want high cohesion, meaning related things are grouped tightly together, and you want low coupling, meaning unrelated things aren't tangled up with each other.
And this help-spec file has extremely low coupling.
Exactly. It doesn't even know the rest of the app exists. It only knows about the help function.
And that means if you accidentally break the help functionality while coding, you know exactly where to look. You aren't distracted by 500 lines of unrelated PDF parsing code.
The cognitive load drops to zero. You are only solving one single problem at a time.
The actual test logic inside the file is beautiful too. It reads spec equals describe quote dash dash help or dash h flag unquote.
Very readable.
Right, and then there are two blocks inside that. One checks if it outputs the correct help text when dash dash help is used. The other checks the shorthand dash h.
And notice the custom helper function he uses there, run full parser.
Yeah, I saw that.
He passes an array with dash dash help as an argument. He gets a result back and then uses expec help to validate that result. It's highly declarative.
Meaning it tells you what the system should do, not necessarily how it does it under the hood.
Exactly. And because of that, it serves as living documentation. If a new junior developer joins the team tomorrow and wants to know exactly how the help flag is supposed to behave, they don't read the main app code. They just read this one tiny test file.
Now, I do have to play devil's advocate for a second here.
Please.
We've taken one single file and split it into 5 different files. Does this affect performance? Because I feel like there's a common misconception, maybe from web development, that if you split things into many files, it gets slower. Like the computer has to work harder to open all those individual doors.
That's a very common worry, especially if you're coming from interpreted languages like JavaScript or Ruby, where loading more files at runtime can actually equal more network requests or disk reads.
Right.
But remember the context here. Haskell is a strictly compiled language.
Ah, okay.
That hspec-discover tool, our sous chef, it does all of its work before the final executable is ever built. It bundles everything into one highly efficient binary file. The computer at runtime doesn't care if the source code came from one file or 100 files.
So by the time the code actually runs, it's all just one solid block of machine code anyway.
Exactly. The modularity, the 5 different files, that is purely for you, the human. The compiler flattens it all out for the machine. So the machine is perfectly happy, and the human developer is happy because the code is readable.
And the proof of that speed is right there in the source. In section 4 of his notes, Ang runs the command stack test to execute the suite. Let's talk about that output.
It's a beautiful output because hspec now knows about the modular file structure. It automatically groups the terminal results. You see a clear header that says help, then the green check marks under it, then a header for txt file, then the checks under that.
It builds a hierarchy. It's not just a massive wall of text saying passing, passing, passing. It's a structured report on the health of different isolated parts of the system.
And did you catch the speed metric at the bottom?
I did. He lists 7 examples, so 7 individual test cases across all these different files. And the final line says finished in 0.00028 seconds.
2.8 milliseconds.
7 tests, 0 failures, under 3 milliseconds. That is staggeringly fast.
It's functionally instantaneous. And that speed is absolutely critical for what developers call the inner feedback loop.
The inner feedback loop.
Yeah. If your test suite takes 10 minutes to run, you naturally stop running it. You only run it right before you push code at the end of the day. You procrastinate.
Because you don't want to sit staring at a loading bar for 10 minutes.
Right. But if they take 3 milliseconds,
You run them constantly.
you run them every single time you save a file. You write a line of code, you hit save, you see a green light, you write another line, save, see green. You're constantly, rapidly validating your plumbing.
It completely changes how you code.
It does. You become much more confident, much more aggressive in your refactoring because you know you're never more than a few milliseconds away from the system telling you if you broke something.
Speaking of plumbing, I want to pivot a bit.
Sure.
We've geeked out quite a bit on the Haskell code, the GHC compiler flags, and the hspec-discover tool. But usually, on a deep dive, we focus really heavily on the content. Today, I want to spend a moment on the author himself. Yes, because digging into qianmeng.org was, well, it was a trip.
Oh, it is a fascinating rabbit hole of a website.
So we know he calls himself an old software plumber. And that sets a very specific tone, right? Practical, grounded, seen it all. But looking at the sidebar of his blog, this man is an absolute machine of categorization.
He really is. The sheer volume of content is staggering.
Like we're looking at notes on Haskell Programming, part 66.
Which is impressive on its own.
66 deep, highly technical posts about a notoriously difficult language. But then you scroll down the page, notes on gardening.
Do you have the exact number there?
Part 817.
817 distinct posts about gardening.
And it keeps going. Notes on fish keeping, part 202. Notes on photography, part 229. He even has notes on betta spawn logs. And notes on propagating Brazilians, which I assume, and really hope, is a type of plant.
I am fairly certain he means the Brazilian verbena plant or something similar, but this paints such a vivid, holistic picture of the author, doesn't it?
It really does.
This isn't just a coder. This is a taxonomist at heart. This is someone who observes the complex world around him, breaks it down, categorizes it, and meticulously logs it.
It connects back to that plumber metaphor so perfectly. And actually, maybe even a gardener metaphor.
Absolutely. Whether he is looking at a tank of fish, asking, will guppies eat algae? Which, by the way, is the actual topic of part 202, or whether he's looking at a Haskell test suite, he's applying the exact same fundamental mindset.
Which is what, exactly? How would you define that mindset?
Observation and order. He looks at a system, whether it's a raised garden bed, a freshwater aquarium, or a code base, and he asks, is this healthy? Is this orderly? Or is entropy starting to take over?
Writing 817 posts about gardening required the exact same kind of steady, unglamorous, incremental effort as refactoring a legacy codebase.
Right. It's not about being a 10x rockstar ninja developer who builds a whole startup in a caffeine-fueled weekend. It's about showing up every single day.
Because a garden doesn't get finished.
Exactly. You don't plant a garden and then just walk away forever. It requires constant daily maintenance. Pruning the dead leaves, changing the water in the tank, cleaning up the test file so it doesn't get overgrown.
Software is exactly the same.
It is. I think that's why that bloated spec.hs file bothered him so much on a visceral level. It wasn't just inconvenient for merge conflicts, it was structurally unclean. It was like weeds taking over his flower bed.
The ecosystem is out of balance. The tests are choking the actual logic.
Precisely. And that mindset, that gardener's mindset, is what truly makes someone a senior developer. A junior developer might write that 2,000-line test file and think, hey, the test run, the light is green, my ticket is closed, who cares?
Right, job done.
But an old software plumber looks at it and knows, this works, right now, today, but it will rot later. I need to fix the underlying structure before it collapses.
And that fix, the hspec-discover tool, is just the perfect pair of pruning shears for the job.
To extend the metaphor, yes, absolutely. It's a tool that automates the pruning process. It ensures that every single new branch you plant, every new test file, is automatically recognized and watered by the system without you having to manually run the hose out there.
It's also interesting how all his blog titles follow that same pattern. Notes on.
Yeah.
It implies a continuous, never-ending learning process. He's not writing the definitive, final guide to fish keeping. He's writing notes. He's acknowledging he's still figuring it out.
That's the real humility of the plumber. You're never actually done learning your trade. Even at part 66 of his Haskell journey, he's still actively finding new, better ways to organize his basic files. He's not rigid. He's evolving his process.
So let's wrap this up and bring it all back to you listening.
Yeah.
We started this deep dive talking about the junk drawer.
Right, the universal developer struggle.
We saw how Ang took his junk drawer, that giant test/spec.hs file, and turned it into a neatly organized, automated filing cabinet using hspec-discover and that one very specific GHC option line.
Just to reiterate it, that's options_GHC-F-PGMF hspec-discover.
And we learned that this modularity didn't cost him a single millisecond of runtime speed. In fact, it gained him massive development speed because he completely eliminated those merge conflicts and drastically lowered his cognitive load.
Modularity is sanity. That's the real headline here.
Modularity is sanity. I like that. So here's my question for you, the listener. And honestly, maybe for you too, expert.
Great way. Go for it.
What is the bloated file in your life right now? It doesn't have to be Haskell. It doesn't even have to be code. Maybe it's a generic utils.py file at work that somehow has 50 completely unrelated functions shoved into it.
Or maybe it's a spreadsheet. I've seen corporate spreadsheets that are essentially entire operating systems held together by nothing but macros, hope, and prayer.
Oh, we've all seen those. We've all been there. Or, maybe it really is just that actual junk drawer in your kitchen.
Yeah.
Ang showed us that sometimes you can't just willpower your way through the mess. You can't just promise to be cleaner next time. Sometimes you need to implement a tool, a specific mechanism, to enforce and automate the order.
You need to start manually importing your chaos and start automating your structure.
Wow. Stop manually importing your chaos. That is the quote of the day.
I might actually put that on a t-shirt.
We'll add it to the merch store right next to Old Software Plumber. Well, thanks for unpacking all this Haskell plumbing with me today.
It's always a pleasure.
And to everyone listening, good luck with your pruning. We'll see you on the next deep dive.